First, the bad news. SAP Business AI won't help you generate cubist versions of your family's holiday photos. But it will help you understand which supplier is best to help you roll out your plant-based packaging in Southeast Asia, or identify the training your junior project manager needs to rise up the ranks, and automate repetitive tasks while you focus on big innovations, so you can be ready for the next opportunity. Revolutionary technology, real-world results. That's SAP Business AI.
Waiting for mortgage rates to drop could be a costly mistake. Once rates drop, new homebuyers will enter the market and prices will soar even higher. At Churchill Mortgage, you can get a free analysis and learn how to avoid the trap of waiting for interest rates to drop. Buy now and refi later at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
This is SpaceTime, Series 26, Episode 82, for broadcast on the 10th of July, 2023. Coming up on SpaceTime, the planet that shouldn't exist. The Sun blasts out another strong X-class solar flare. And the Australian government scraps $1 billion satellite program. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a planet that by all accounts shouldn't exist. Located some 520 light-years away, the planet 8 Ursae Minoris b is orbiting a red giant in the constellation Ursae Minor, the Little Bear. But the thing is, this planet should have been destroyed when it was engulfed during the star's expansion phase into a red giant, part of an evolution that will ultimately see this star become a white dwarf. White dwarfs are stars like our Sun that have used up all their core hydrogen fuel, fusing it into helium. This causes the stellar core to cool and contract. And this contraction increases pressure and temperature in the core, eventually getting high enough to fuse the core helium into carbon and oxygen. At the same time, all this extra heat is causing the star's outer gaseous envelope to expand. And now being further away from the stellar core, the surface of the stellar envelope cools down, turning the star into a red giant. This process happens over and over again in a series of pulses, and during these pulses, the outer envelope engulfs and destroys any nearby planets. In fact, this is the very fate our own dying Sun will inflict on the inner planets of our solar system in between 5 and 7 billion years from now. Our Sun too will expand into a red giant, engulfing and destroying the planets Mercury, Venus, and most likely also the Earth. Eventually, be it 8 Ursae Minoris or our Sun, the star's outer envelope will simply puff off, floating away as a planetary nebula, leaving behind the star's exposed white-hot stellar core, a white dwarf, which will then be left to slowly cool over the eons. Until now, scientists have thought that no nearby planet can survive this process. However, a new study reported in the journal Nature has confirmed the existence of the planet 8 Ursae Minoris b, which seems to have survived the deadly expansion against all odds. The planet, which is also known as Hala, is orbiting close to the dying red giant star and well within the zone that would have been wiped clean during the star's expansion phase. Hala is a hot Jupiter-like gas giant. The planet is composed of swirling gas with a surface temperature of around 1000 Kelvin, that's 730 degrees Celsius, making it hotter than any planet in our solar system. One of the reasons behind this heat is the planet's closeness to its host star, which at 75 million kilometres is about half the distance between the Earth and the Sun. And as for the star itself, well, it's expanded out to around 20 times the diameter of our Sun. One of the study's authors, Dr. Ben Monet from the University of New South Wales, says this is a planet that simply shouldn't exist. It should have been ingested by the star. Astronomers have known about HALA since 2015, when a study using the radial velocity method, a technique which analyzes the slight gravitational tug an orbiting planet can have on its host star, suggested that a planet must be orbiting the star 8 Ursae Minoris, which is also known as Baekdu. The new observations confirm this discovery, showing that HALA's nearly circular 93 Earth-day orbit around the star has remained stable for well over a decade. The findings are based on observations from the Canada-France-Hawaii Observatory and the twin Keck telescopes upon Mauna Kea in Hawaii. The authors also used NASA's TESS Transiting Exoplanet Survey satellite in order to undertake astroseismology observations of the star, studying its oscillations to help uncover its internal properties. Astroseismology measures pressure waves or starquakes inside the star in the same way that geoscientists learn about the Earth's interior by studying earthquakes through seismology. This confirmed that Baekdu was in fact burning helium at its core, a phase that red giants only reach after they've already swirled up and consumed nearby planets. And this makes HALA the only planet we know closely orbiting a star in this late stage of life. The discovery raises some interesting questions. Is the planet breaking everything science knows about stellar planetary evolution? Or could there be another equally bizarre reason behind its survival? Monte and colleagues didn't take long to spot something strange. They detected a lot of lithium in the star's atmosphere. And this is unusual because most stars don't have lithium. It burns too easily in stellar atmospheres. While lithium is often seen in young stars, only about 1% of older red giants possess it. One of the leading theories to explain why some older stars are mysteriously lithium-rich is that they've gained their lithium later in life, most likely by way of an interaction with another star. Now, if that's the case, our authors have come up with 3 possible scenarios. One involves Baekdu itself being the result of a merger of 2 stars in a binary system millions of years ago. And this merger could have restricted one of the stars in the binary system from expanding wide enough to engulf HALA, thereby allowing the planet to escape. Or it's possible that HALA itself wasn't in danger in the first place, simply because it didn't exist before the star's expansion phase. Instead, it might very well be a second-generation planet, born from the ingredient-rich gas cloud created from the merger of the 2 stars. A third option involves a long-term trend in the star's radial velocity signal, suggesting there's something else there, another nearby object, and that's having a slight gravitational pull on Baekdu. But whether it's a star or a planet, or whether it's even played a role in somehow influencing HALA's current orbit, is still a mystery. This discovery is important because it shows that not all close-in planets are doomed at the hands of their host stars when the star begins to grow old and become bloated. Monte says there are about 1,000 other lithium-rich giant stars out there that we already know of, and this could be an exciting opportunity to search them out in the hope of finding more nearby planets. He points out that there aren't many of these stars that have been studied in detail, simply because they shouldn't have planets around them. But we've been surprised once now, and we'll probably be surprised again.
Yeah, this is a planet that's in a really surprising place. We know when a star is at the end of its life, it will expand, become a red giant, but that's a fairly short-lived phase. It becomes a red giant very briefly, and then it contracts back down and goes through a long, hundreds of billions of years phase called the red clump, where much like our sun, it will be burning things in its core. But unlike our sun, which is turning hydrogen into helium, this star has used up all its hydrogen. It's converting helium into carbon. But it's already been through this expansion and contraction phase. And so in this case, we see a planet that is in a fairly close orbit to its star. That's weird. We know when the sun goes through this phase, we expect it to swallow up Mercury and Venus and possibly even Earth. It's going to grow that large, about what we call 1 AU, the size of the distance from the Earth to the sun. This star went through that phase too, so we would expect it to swallow up anything in these short periods, but this planet seems to have avoided that fate.
You can see the planet directly, I take it, or how do you know it's there?
Yeah, that's exactly right. So we don't see the planet specifically. We see its effects on its host star. So in this case, we see it through a method called Doppler spectroscopy. We measure the velocity of the star, looking at how quickly it's moving towards or away from us, and we see that change it. And that's because it is being orbited by this planet, and so really these two objects are both gravitationally tugging on each other. So as the planet goes around the star goes around the planet a little bit as well. And so we see that reflex motion through a Doppler shift. The wobble method, exactly. In the same way that we see or we hear a police siren or a train or a race car change pitch as it moves past you, we see the same thing in light from stars. The star becomes slightly bluer or redder over time, and we use that to infer the presence of a planet. We can work out the period and how big the planet is based off of how long the signal takes and how big it is.
And you also used astroseismology in this study as well.
Absolutely, yes. So astroseismology is the study of pulsations in a star. Stars are big balls of gas. They behave like fluids. And so in the same way as you skip a rock on a pond and you see the ripples, stars have ripples inside of their interiors as well. And the speed that these ripples go through the star, the way they go through, tells us what the interior of the star looks like. How dense is it? What is its composition? What magnetic field? So we can really learn a lot about stars through these ripples. And so in this case, that's what enabled us to understand that the star is this evolved red clump star where it's already been through the red giant phase, not just expanding up for the first time. So this star will go through several phases of expansion and contraction. It loses a little bit of mass each time, but the main loss of the outer layers, the main planetary nebula contraction is in the future. So it's been through this first step, this red giant branch where it becomes something like 100 times the radius of the sun. It's contracted back down to about 10 times the radius of the sun. But it will, as it runs out of helium in its core, it will go through this process again. It'll go through it a couple times on its way to eventually becoming a white dwarf with a planetary nebula around it.
What makes this special? Just the fact that the planet survived? I'm assuming that's what we're talking about here.
Yeah, so it's special in that we don't really understand why this planet is there. The theory would predict this planet doesn't exist. It should have been swallowed up. And so either it survived through some mechanism or it wasn't there in the first place, that perhaps there was interaction with another star that put some material in orbit in a disk later on in the star's life that the planet was able to coalesce from. We call these second-generation planets. So a planet that arrived later on in the lifetime of the star. And it's possible that happened. We don't really have the data to say.
Yeah, there are three theories associated with this, aren't there, that could explain what we're seeing?
Yeah, absolutely. So one of the things that's weird about this star, beyond that it has a planet, is that it has a lot of lithium in its atmosphere. Now, lithium is an element that doesn't stick around long inside of stars. It's very easy to burn, to separate out into other elements.
Even brown dwarfs have them.
Brown dwarfs have them, yes, and very young stars have them. And so we use it to measure the ages of stars, of young stars, based off how much lithium is left. Stars have characteristic, we call it depletion timescale, so how long it takes to use up their lithium. And so this star's timescale should have been 10, 20 million years. It wouldn't have had lithium for very long, and yet it's billions of years old, and there's a lot of lithium in its atmosphere. We see this about 1% of the time in these red giants. We've seen them for about 50 years. It's a long-standing mystery why these stars have lithium. But one of the main theories is that it's the result of a merger, that this star had a second star in orbit in a binary system, and perhaps that star got swallowed up along the way, or in some way was able to perhaps get ejected from the system, but it somehow shielded this planet from being swallowed up, affected the evolution of the star, so that it didn't quite go through this red giant phase in the way that stars normally do.
Now, this particular system was found using TESS, I was going to say planet hunting, but it's really more planet confirming spacecraft of NASA.
TESS is a little bit of everything. One of the things that's really exciting about TESS is that it's really useful as a stellar astrophysics probe as well. And so TESS was really useful for the system. There was another team years ago that identified this planet as a candidate using ground-based data, but they didn't understand the star very well. And so TESS was critical for understanding this is a star on the red clump. It's through the red giant branch, through the astroseismology. That would not have been possible without TESS. So that played a key role. And the other telescope that was really important was the Keck telescope in Mauna Kea, Hawaii. It has a spectrograph called HiRes on it, which is really one of the world's best telescopes for doing these Doppler shift measurements, looking for the wobbles of stars because of planets. That enabled us to really precisely characterize the mass of the planet, the size of the planet, verify that it was there, and also identify that there's some long-term extra acceleration from the velocity of the star. So something else is pulling on the star, perhaps it's a binary companion in a wider orbit or another planet in the system that we don't quite have the data to characterize yet. So there's exciting times ahead.
That's Dr. Ben Monte, an astronomer with the University of New South Wales. And this is SpaceTime. Still to come, the Sun releases a strong X-class solar flare, and the Australian government scraps $1 billion satellite program. All that and more still to come on SpaceTime.
Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to its signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
The Sun has emitted a strong X-class solar flare. X-class flare is the most violent and intense type of solar flare. The event was captured by NASA's Solar Dynamics Observatory spacecraft, which constantly monitors the Sun's activity. Solar flares are powerful bursts of energy exploding out from the Sun's surface due to sunspot action. If pointed at the Earth, flares and coronal mass ejections, powerful explosions sending the Sun's matter into space, can impact radio communications, satellite navigation systems, electric power grids, damage spacecraft, and be a threat to astronauts by increasing radiation levels. This latest blast came as the sunspot count for the average number of sunspots in June hit a 21-year high. It means that solar cycle 25 has shot past its predecessor, solar cycle 24, and may now be on track to rival some of the strongest solar cycles of the 20th century. This is SpaceTime. Still to come, Australia scraps $1 billion satellite program. And the United States launches a new top-secret spy satellite on what will be the second last ever launch of a Delta IV Heavy. All that and more still to come on SpaceTime. After scrapping millions in funding for rocket launch facilities in Australia last month, the Albanese government has now axed a $1.2 billion satellite Earth resources program. The National Space Mission for Earth Observation project was designed to develop a series of satellites that were key to developing Australia's space industry, providing Australia with the capabilities to design, build, and launch its own spacecraft. The global space market has grown to a record $469 billion in annual global spending in 2021, and up from $280 billion in 2010. And it's expected to pass $1 trillion by 2030. The former coalition government wanted Australia to have a significant slice of that market. The Australian project was to build and operate an initial 4 satellites, which would be launched between 2028 and 2033, in order to garner Earth observation data to help with weather forecasting, farming, environmental management, forestry control, national disaster assistance, and defence security measures. The Space Industry Association of Australia says the decision to cancel the satellite program was short-sighted and will undermine the Albanese government's agenda on climate, defence, STEM, advanced manufacturing and building tech jobs. Last week, Federal Treasurer Jim Chalmers boasted about the Labor government achieving a budget surplus for the 12 months to May of $19 billion, well above the $4.2 billion flagged in the 2022-2023 financial year in the last federal budget. This is SpaceTime. Still to come, the penultimate Delta IV Heavy rocket blasts off from Cape Canaveral carrying a top-secret spy satellite. And later in the science report, the World Meteorological Organization formally declares that an El Niño event is now underway. All that and more still to come on SpaceTime. The penultimate flight of the massive United Launch Alliance Delta IV Heavy has taken off from Cape Canaveral in Florida, carrying a top-secret spy satellite into orbit. The NROL-68 mission from Space Launch Complex 37B had been delayed by a day following an issue with the ground system pneumatic valve. The 72-metre-tall Delta IV Heavy is made up of 3 Delta IV core stages mounted side by side, forming one of the most powerful rockets in the world, one capable of lifting more than 14 tons into geostationary orbit. As well as the 3 common core boosters, the launch vehicle configuration also used a cryogenic Centaur upper stage and a 5-metre diameter payload fairing to protect the classified National Reconnaissance Office spy satellite. NROL-68 marked the 15th launch of a Delta IV Heavy, which first flew in 2004, and it was the 11th Delta IV Heavy mission for the National Reconnaissance Office. The final Delta IV Heavy is slated to launch next year. There are now only 3 missions still planned using either Delta or Atlas rockets, both of which will be replaced by the United Launch Alliance's new Vulcan Centaur rocket sometime in the next year or so. We'll keep you informed. This is SpaceTime.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization has formally declared that an El Niño event is now underway. Scientists say warm eastern tropical Pacific sea surface temperatures have now confirmed the presence of El Niño with a 90% chance of it continuing into late 2023. The World Meteorological Organization has combined forecasts and expert opinions from around the world to declare the onset of the El Niño, which is set to increase the likelihood of record-high temperatures in many parts of the world. The El Niño and La Niña Southern Oscillation weather patterns, known as ENSO, act as the primary meteorological driver influencing Australia's weather and climate on a year-to-year basis. It's a naturally occurring shift in tropical ocean temperatures and weather patterns along the equatorial Pacific, causing a change in atmospheric circulation. These cycles loosely operate over timescales ranging from 1 to 8 years. El Niño, meaning little boy or Christ child in Spanish, causes extended periods of warming sea surface temperatures in the central and eastern tropical Pacific with high surface pressures in the tropical western Pacific. And that includes Australia. The name comes from Peruvian fishers who noticed reduced catches of anchovies at Christmas time during periods of unusually warm water in the Pacific Ocean back in the 1600s. El Niños tend to cause periods of warmer temperatures, reduced rainfall, increased drought, and high fire danger across Australia. While the Americas tend to experience increased rainfall, flooding and storm activity, with the Pacific jet stream moving south causing drier and warmer conditions in the northern US and Canada, while the US Gulf Coast and southeast become wetter than usual with increased risk of flooding. Now, typically, the equatorial trade winds blow from east to west across the Pacific Ocean during El Niños. El Niño's counterpart, La Niña, or Little Girl, we've just experienced 3 of them in a row by the way, is associated with lower sea surface pressure and extended periods of cooling equatorial sea surface temperatures in the central and eastern tropical Pacific. It also generates persistent southeasterly to northwesterly winds, strengthening in tropical latitudes with clouds shifting west across the Pacific closer to Australia. La Niña results in increased rainfall and flooding across eastern and central Australia, with more storm and tropical cyclone activity likely, and a weakening or even reversal of the prevailing trade winds, pushing more warm water towards Australia. La Niña can also lead to more severe American hurricane seasons. Meanwhile, the cooler eastern Pacific waters push the jet stream northwards, bringing more drought conditions to the southern US and heavy rains and flooding to the Pacific Northwest and Canada. During a La Niña period, US winter temperatures are warmer than normal in the south and cooler than normal in the north. Planet Earth's average temperature has set a new record, reaching 17.18 degrees Celsius for several days. And that was after setting the previous record of 17.01 degrees Celsius the previous day. The latest records, based on data from the US National Centers for Environmental Prediction, beat the old record of 16.92 degrees Celsius, which was set back in August 2016. The new high was also the warmest since satellite monitoring first began in 1979. Scientists say the new record is due to a combination of the latest El Niño weather event and ongoing emissions of carbon dioxide and other greenhouse gases. The record comes as the southern US, China and North Africa all suffer record heat waves. And they warn there'll be more records in coming months as El Niño strengthens. The average temperature across the planet is now 1.46 degrees Celsius above the average during the period 1850 to 1900. Meteorologists warn that the new El Niño phase means we can expect a lot more daily, monthly and annual record-breaking events over the next 18 months. The Reuters news agency is reporting that one of the world's most common artificial sweeteners is set to be declared a possible carcinogen next month by the World Health Organization. Dr. Ian Musgrave from the University of Adelaide says the sweetener aspartame will be listed as a Class 2B carcinogen, meaning it's possibly carcinogenic to humans. This means there's some evidence for carcinogenicity. But Musgrave says, to put it all in perspective, hot beverages are listed as a Class 2A probable carcinogen. So there's less evidence for aspartame being a carcinogen than there is for drinking hot beverages. He says the most recent systematic review of non-sugar sweeteners found no consistent evidence for carcinogenicity from epidemiological studies and no evidence relevant to humans of carcinogenicity in trials. Musgrave says, in short, the evidence of any human risk is very weak, and if you're not going to worry about your risk from a hot cuppa, then the aspartame you put in it will be even less of a worry. What UFOlogists want more than anything else in the world, beside actual proof of extraterrestrials, is for some serious people to pay serious attention to them. The problem, of course, is that once you get really serious investigations by real scientists, you tend to get real results. And as Tim Mendham from Australian Skeptics puts it, that's never good news for ufologists.
The great thing about most UFO proponents, several things probably, is that most of them are genuine, right? There are hoaxes out there, obviously, but most of them are genuine. They really want evidence and proof of their beliefs, and that's great. There's a lot of areas, especially in medicine, where people run away from any evidence, but the ufologists, same as the cryptozoologists, the people looking for unknown animals, always want evidence. Now, suddenly when you get a high-profile examples like the Pentagon UFO films that was recently released, even though they'd been known about for about 10 years or something, that caused a big fuss. Everyone got interested, and therefore suddenly people started paying more attention to UFOs, or UAPs as they're called these days, unidentified aerial phenomena, although someone calls it unidentified anomalous phenomena, which is a bit annoying because it makes it seem anomalous. But UAPs or UFOs, all flying saucers, creates a lot of interest. These Pentagon things created a lot of interest, despite the fact that the Pentagon result was that we don't know what they are. Good heavens, they're unidentified. Unidentified flying objects.
Others were artifacts in the camera equipment, the lenses, and others were simply unexplained glitches.
Yeah, as the researcher Mick West pointed out, that it's amazing how poor the Pentagon investigation was when they came down and said, we don't know what these are. And he looked at them, did a few experiments, and pointed out within hours what they were.
Which we reported on, yeah.
And the thing is, you do not go to ufologists, by and large, especially major proponents, and say, is this a UFO? Because they say yes. Although I've discussed things with a number of UFO proponents, including the world's most prestigious collector of UFO photography, which is a fellow in Spain.
Oh, yes, he's written books denouncing it too, but hasn't he?
Yeah, absolutely. Yeah, he's a serious. He's a believer, or wants to be a believer, but he wants to believe in scientific evidence. And the problem is that as soon as you get this excitement going on, you get real people who, with a slightly more independent point of view, investigating. And the trouble is then you expose your, quote, science, close quote, to more scientific rigour. And what's happening with the scientific rigour is that they're finding nothing there, as happens with Mick West when he investigates these things. You do not ask your people running the UFO Society to ask them, are there such things as UFOs?
Most scientists I know, most astronomers and physicists I know will tell you they believe there is probably life beyond Earth, life on other worlds. But those worlds are a long way away, far too far for those people to have travelled here. That's the problem.
That's the problem. There may be life out there. Heaven knows there might even be intelligent life out there. And that's
certainly none here.
Boom. Yes. But, I mean, they're probably not here. And that's the trouble. And the trouble with UFO evidence is that it's a lot of bad evidence. There's a lot of evidence, but it's bad evidence. If you mark it out of 10, you probably get a lot of 2s. And a lot of 2s don't make a 10, right? They don't add up. It just means there's a lot of bad evidence. And the trouble is when you get a lot of bad evidence, the implication is maybe the whole thing is bad. It's a shonky science. If you keep doing experimental results and they keep turning out, you're probably going to say, well, it's probably not worth pursuing. That's the trouble. UFO proponents, the ufologists, and et cetera, want scientific proof, want scientific investigation, but when they get it, they don't necessarily like the outcome because it is saying, almost without failure, that there is nothing there worthwhile looking at.
It was two hubcaps stuck together.
Well, and literally so in some cases. I mean, I've had people give me evidence for UFOs and things, which is patently pathetic. And these days, of course, with everyone having smartphones and smartphones with what is the technology that stops the jiggling, stops the picture shaking, they can counter for that. If the UFOs are out there and so common, there should be gazillions of bits of evidence which is decent quality, sharp enough.
Same with Bigfoot.
But all you get is fuzzy photos from a shaky camera. And one person came to me and said he kept filming UFOs from his balcony. And I said, well, it's a shame you don't lean against the balcony wall, because then your camera wouldn't shake so much. And you wonder, why is your camera shaking so much?
Is balcony north-facing? Because he's probably seeing aircraft coming into land on 16 right at Sydney Airport.
He was fairly near an aircraft thing, but I actually sent his videos over to Mick West and this fellow in Spain, who are the experts on it, and they both came back saying balloons.
Okay.
And saying balloons meant the person who gave me the videos was rather upset. And of course he said, well, of course, the skeptics would say they're balloons. Well, yeah, because they are balloons.
How do you win then?
You can't. You can't win against the fervent believers, but I mean, you have to look at the evidence. You keep saying a lot of bad evidence doesn't amalgamate into good evidence. It just means the evidence is getting worse and worse and worse. The trouble is that when you're looking for results and you ask the serious independent people to look into it, you're going to get not necessarily the result you want. But that's the trouble, because most ufologists, most serious ones I know, are genuine people doing what they regard as genuine research, and they are on the believing side of skeptical, but they are still sort of trying to find the evidence which is definitive, and there is no definitive evidence.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.